All right, folks, here is the primary current injection test. This tester can go up to 30,000 amps, and the nameplate is fairly self-explanatory. You have the controls on how much current or how much time you want to inject. So on the left side you have the timer, on the right side you have the meter for the current. Now the concept, and you have some handles for the current, and the concept is to apply the primary current to the breaker and then monitor the operation of the breaker. The breaker we have is DS type. The trip unit model is AC Pro, and you can go over the menu to read the settings off of that. After we have all the good connections, we start injecting the current. The pickup, long time pickup, is 1600 amp, and we increased the current until this pickup LED indicator light starts blinking, and that's where you record your pickup current. So it picked up around 1600 amp, but you need to record the exact value. You can drop the current until the pickup LED light turns off. That's gonna be the long time pickup. The next test is gonna be the long time delay. The long time delay is 3 seconds. We can find the minimum and maximum, the range, the expected range to trip for this breaker using the TCC published by the manufacturer. We're gonna test it at 3 times. So what we're gonna do, we're gonna pulse 4800 amps, and we're gonna time it, see how much time it takes for this breaker, phase A, to trip at 4800 amps.
Tripping breaker.
So right now it's 4894. Roughly, we have a tolerance. And you see the timer on the bone crusher, the trip time 11 seconds, 0.69 at the current 4920 amps. And this is what we record on the test form. Similar test is gonna be done to the short time. We did the long time pickup, long time delay. Now we're gonna do the short time. The breaker was tripped. Now we close the breaker. The breaker is closed. We're gonna pulse it and see where it picks up for the short time. And we record the current. The current shown on the tester is 6160 amps. We have to multiply the displayed value by 1000 because the unit for these amps is kiloamps. The time, you can have it either in seconds or you can change it to cycles. And this is the adjustment for the current. All right, so we are done with the short time pickup. Again, the breaker was tripped, we closed it again. Now we are ready to do the last test for this breaker, because this breaker has only the long time and short time settings. It does not have instantaneous or ground. Now the short time delay is gonna be the last test. For the short time delay, we usually do it at 1.5 times short time pickup. You can go higher, but since the I2T is out, we have the flat line delay. All right, now we are doing B phase. B phase is connected in the back. And for the B phase, right now we are doing the short time delay. For the short time delay, as I explained, typically we do it at 1.5 times the short time pickup. Short time pickup for this trip unit is set at 6,000 amps, 1.5. View the settings. So let's go through the settings. This is the last trip. The information for the last trip and review. This is the serial number, the CT rating, the primary 1600 amp, long time pickup 1600 amp, long time delay is 3.0 S, stands for seconds. The short time pickup 6,000 amps, short time delay 0.10 S, stands for seconds. Short time I squared T off, they display that I SQT, I squared T is off. Instantaneous pickup, I stands for instantaneous, there is no instantaneous. GF, ground fault pickup, off, there is no ground fault setting on this. Unbalanced pickup, it is off. Ground fault quick trip, off. Instantaneous quick trip pickup 2400 amps. Thermal memory, off. And that was it. That was all the settings we had for this trip unit. So what we're gonna do, we're gonna do the short time delay one more time. The setting is 6,000 amps. We're gonna do that 1.5 times the pickup, which is gonna be 9,000 amps. We're gonna inject 9,000 amps to this breaker and then record how much time it takes for the breaker to trip. Tripping. All right, the breaker tripped. It's in open position. It was closed. Now we injected right on the dot 9,000 amps and the recorded time is 0.117 seconds, which is 117 milliseconds. And then we compare it with the TCC curve to see if it's within the acceptable range or not. In this scenario, since the I squared T is out and we do have the flat line for the short time delay, it doesn't really matter how much current you inject. The delay time, the trip time should be the same. That's the expectation because the delay is a flat line.